Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Radicals. Question 3, rationalize the denominator. Inbox me at memedicine@gmail.com to order complete study packages. Review question 3, rationalize the denominator. Which expression represents the sum of 1 over radical 3 plus 1 over radical 2, which can also be expressed as 1 over the square root of 3 plus 1 over the square root of 2. Is it going to be 1, 2 radical 3 plus 3 radical 2 over 6, 2 radical 3 plus radical 2 over 3, 3 2 over radical 5, or 4 radical 3 plus radical 2 over 2? Definitely press pause if you need to, and I'll give you a moment to think. All right, so as the title implies, the first step that we're going to have to do to analyze the sum is rationalize the denominator. Rationalize has the root word rational, and rational numbers are numbers that can be expressed as simple fractions, okay, with integers in the numerator and the denominator. And integers are any number that you can find along the number lines, including numbers with terminating decimals that may not always, they may be hashed off on a number line, but not clearly indicated. So numbers like 1.5, 0, negative 2.3, okay, so all the negative and positive numbers, including zeros, and so the counting numbers plus, the decimal between the counting numbers or the whole numbers. Okay, so obviously a radical or a square root is not a counting number. It would need to be analyzed, and the square root of 2 or radical 2 is definitely not a rational number because when you try to analyze this, it has a repeating decimal that goes on and on forever, so it violates the definition of a rational number. Okay, so obviously, to unleash the radicand, when I say radicand, I mean the expression underneath the radical symbol. We're going to have to square these terms because remember, there's an invisible 2, an index of 2, associated with every radical or square root. And so to undo finding a root, you just simply raise the expression to the exponent equivalent to the numerical index of the root, okay? So in this case, it's not written, but we understand that it's implied that the index here is 2 or a square root. So let's just go ahead and do that, all right? Another way of looking at squaring is just multiplying by the number or multiplying the number by itself. And remember that algebraically, to maintain the same value without changing the value of the fraction, what we would have to do is multiply by the radical in the numerator also. And to have a rational expression, it's okay to have radicals in the numerator. You just can't have them in the denominator. All right? I know that's a mouthful, but I'll give you tons more practice. So inbox me at memedicine@gmail.com to inquire about purchasing in-depth cram sessions, okay? All right, so we're also going to do the same thing to the second expression. You multiply by radical 2 in the denominator as well as radical 2 in the numerator because our ultimate goal is to unleash the radicand or get rid of the radical symbol, okay? And when we do that, we end up with radical 3 over 3 plus a radical 2 over 2. All right? So now we still don't have one monomial expression. We have two terms, two monomial expressions. So what we're going to have to do now is come up with a common denominator, specifically the least common denominator. And all we have to do that is multiply the denominators, and we find out that the LCD is 6. And the reason why we know it's the least common denominator rather than just any old common denominator is because 3 is a prime number and 2 is a prime number. So we don't have to go ahead and do prime factorization to find out the least common denominator. Because let's say that this were 4. a common denominator would be 12, but it would, yeah. Or let's say we just assign a common denominator to 12. That's not the least common denominator. It's actually 6, okay? So you could do 12 as well, but you would have to end up simplifying further. All right, I don't want to, go off on a tangent too much, so let's get back on track. So yeah, we multiply by the first term by 2 in the denominator and 2 in the numerator to get a common denominator of 6. And we multiply the second term by 3 in the denominator as well as 3 in the numerator to get a 6 in the denominator, okay? And so now we end up with these expressions, and we can combine them now that we have a common denominator. And the correct answer is going to be 2 radical 3 plus 3 radical 2 over 6. And we see that that's answer choice 1. All right? Thanks for tuning in. Good luck studying.